I'm going to do an example, then I'm going to do the problem that's stated here. I'm just going to take a simple linear function because it demonstrates the process, okay? What's the inverse of this? What do you do to do an inverse? What do you know for sure about inverses? Inverse functions.
You flip the x and y values.
Yeah, if you got a table of values, you switch the x and the y's, right? So it switches x and y's. So you got y equals 3x plus 5. So that's your f of x function, right? So it's a very simple process. You replace x with y, you replace y with x. Get this, okay? Here's your inverse function. You want to find out what y is, and right there it is. And we could write f inverse of x equals 5/3. Okay? So what's f inverse of f of x? Well, here's f inverse of x. We've replaced x by f of x. We better replace x by f of x. Right? And then f of x is 3x plus 5. Did I do something wrong? It's coming out a little strange. Oh, no, never mind. It's coming out exactly as it should. Forgot where I was. Okay. Just wasn't paying attention. Okay, so you got this, right? Well, what's that? That's 3x over 3 plus 5 over 3 minus 5 over 3. And that's equal to x. So now I know I've got the inverse function, because what this says is, if I take my function and then I apply the function where the values are switched, I get the values back where they should be. Actually, you won't understand that from the words, and I don't want to take time to draw it out. But right there, we have it. That's a check. Now, the problem your book gives, you should be in pretty good shape to do this. When you got f of x equals 8 times the log, what base? Get that. That's a small number. Base 9 of x to the 5th, x to the 6th. Is that negative 6th? It's a 6th. X to the 6th plus 5. Okay? So you got y equals 8 log base 9 of x to the 6th plus 5. You swap x and y, you get x equals 8 log to the base 9 of y to the 6th plus 5. And then you solve for y. Okay, so what's the first thing we do if we solve this for y? Well, we have to get it in the form log base 9 of y to the 6th equals something, so we can change it to exponential form. And your reflexes on that were pretty good a month ago. And they weren't too bad last time I looked. So that's something you'll understand. Okay? So you get x minus 5 equals 8 log base 9 of y to the 6th. And of course you want to write out your steps. But by now, you'll understand why I'm doing what I'm doing. So log base 9 of y to the 6th equals x minus 5 over 8. So y to the 6th equals e raised to the x to the 9th minus 5 over 8. That's not e, it's 9. So y equals 9 raised to the x to the 9th minus 5 over 8 to the 1/6 power. Now, I imagine everybody did that in their head before I could write it out, right? Nothing to it. Well, you just follow your wits and you do this, okay? So I think if that one popped up on your assessment, probably wouldn't put that on. But, yeah, if that popped up on your assessment, and you remember what you do to do an inverse function, you just swap x and y and solve for y. Okay? I think it would be rare for anybody in any pre-calculus course to get all the way to that. Rare meaning not astonishing. Out of 100 students, I'd expect a few to get all the way to there without screwing it up, so see if you can. Okay? But my feeling is most of you are in a shape where you could probably score higher than the median score on this thing, which is probably about 0.9 out of 5. Okay? Less than 1 out of 5. Okay? That'd be worth doing. Even if it isn't a required problem, it could be. Because it could pop up. Even if it isn't a required problem, if you were to get all the way through that or even make a really good attempt at it, I'd give you some extra credit.
Where'd x to the 9th come from on that?
Log base b, you get b to the power, right? It's your rule for changing log to exponential form. Okay? So you want to review that, but that should be pretty obvious. So think about it. You know, that comes from a log base. I don't remember what letters I used, but that equivalence. It's the inverse function equivalence for log and exponential. So it comes from the fact that the log base 9 is inverse to the 9 to the x function.
I get that. I mean, you have 9 to the x to the 9th.
Okay, wait a minute. Yeah, why did I write a... Okay, you mean where that 9 came from? Glad you asked. It's just x minus 5 over 8, right? I don't know, I had that 9, I caught it out of the corner of my eye and thought it was a good thing to write. See what I mean? If I don't have a chance of getting it right at the end, what chance does anybody have? But at least make some steps, right? And actually, I think you could do it. Okay, yeah, that was a bonehead error. Okay, fair enough?